Hey y'all, all right, so today we're going to be talking about what is molarity. So this video doesn't really touch on what a mole is too much or how to solve for molarity with the C1V1, M1V1 stuff. That'll be posted in another video. So today is just what is molarity, what is the mole, how do we use it, what does it mean? All right, so we're talking about, make sure I don't reach too high here. The mole, but specifically molarity. Just kind of right off the bat, what is molarity? The unit for molarity is going to be M, capital M, and what that means is the number of moles per 1 liter. So how many moles are in 1 liter? But we're going to kind of back up a little bit, kind of touch on that, explain the concept a little bit. So, in science, a mole was created to kind of make counting very small atoms and molecules easier. You can think about how small, how tiny an atom is or a molecule is. There's, I don't even know the words, billions of trillions of them in a small glass of water. So extremely tiny, it's impossible to count them. So the mole was kind of devised as a way we could count them up. Similar to a dozen. So, pretty much everybody in America knows if you go get a dozen donuts, you're going to come back with 12. It don't matter if they're chocolate-covered donuts. It don't matter if they're cream-filled donuts. It don't matter if they're the donut holes or what type of donuts they are. If you're getting a dozen, you're getting 12. Same thing with a mole. It doesn't matter what the mole is, whether it's aluminum, whether it's water, hydrogen peroxide, methane. It doesn't matter the compound. If you're getting a mole of it, then that's the same amount, regardless of what it is, similar to a dozen. So another way to kind of think about it is like grains of sand and a pile of sand. So if you were, forced to count out sand, grain by grain by grain, it would take forever, right? Nearly impossible task. But if you were to think about it like, okay, what about piles of sand? So here's kind of like my piles of sand. Now the key is each pile has to automatically kind of have the same amount. So we'll say that each pile of sand, has 500 grains. Right? So if I was to try to count out 1,500 grains of sand by hand, it would take way longer than I want to find out. But if I was to kind of have them in piles, then I could be like, okay, well, if just 3 piles, I got 1,500 grains of sand right here. Right, so a mole is kind of like that. A mole is a grouping of the molecules, a grouping of the atoms. So what is the mole? So some guy named Avogadro figured out that if you were to get this many, hang on, it's going to take a second. I think that's right, pretty close. If you were to get this many atoms or this many molecules and get them together, it would equal the mass of whatever it is. So, carbon has an atomic number of 6 and a mass number of 12. So he figured out that if I was to get this many carbons, it would weigh 12 grams. But what's also cool about that, so oxygen has 8 and 16. If I was to get this many oxygen atoms together, it would have a mass of 16. And so he kind of checked it and tried it. And then if you were to get this many water molecules together, which is 16, 1, and 1, it would weigh the mass of water. So this is Avogadro's number, and that's what it means. It's always the same. If you were to get that many molecules or that many atoms of a substance, it would be equal to the molecular weight. That's where the mole comes from.
Kate Sawinski, please report to the front office at this time. Kate Sawinski to the front office.
Sorry about that, but I'm not going to start over. Fortunately, we can write that number a lot shorter using scientific notation. 6.022 times 10 to the 23rd. It's like 602 billion trillion is the other way to say it, I guess, something like that. So, what does molarity do? Molarity is a unit. All right, so molarity is a capital M. This is a unit for concentration. If you're not familiar with what a unit is, gram is a unit for mass. Liter is a unit for volume. Or you could do cubic meters or something like that. Meters is the unit for distance. You know, watt is a unit, volts is a unit, amps. There's units for all kinds of things, percentage, pounds. So mole or molarity is just like that, but it's a unit for concentration. Well, what is concentration? Not thinking real hard, right? So concentration, if you think about things you get at the grocery store, they're concentrated. So you got, you know, certain juices are concentrated, and it's intended that you water them down before you drink them, right? I know you're gonna think this is crazy, but the Campbell's chicken noodle soup comes in the can. It is concentrated. If you read the back of the can, it wants you to pour the Campbell's soup in and then fill that can up with water twice and dilute it because it's so concentrated. It's real salty, but you know, guy like me, you just eat the eat the chicken noodle soup out of the can the way it's meant to be, right? Other things like the cream of chicken soup at the grocery store, it's kind of real thick and gloopy, so you're supposed to water it down before you use it. So concentrated is just a lot. A lot of the substance packed tight together. The opposite of that would be dilute, in which they'd be really spread out. So molarity is a unit for concentration. Specifically, how many moles do we have packed in to a liter of water? This is a base unit. So we're looking at a couple of examples. Let's see if it kind of makes sense. So, hold on. First off, kind of picture what a liter is. This is a 1 liter bottle, right? It says it right here, 1 liter. So when we're talking about molarity, we're talking about how many moles, right? How many of those giant numbers, like the piles of sand, are packed into this bottle. If there's 1 molar, then there's this many packed into this liter. 2 molar, there's double that. 1/2 molar, there'd be half of that, so forth and so on. So a couple examples real quick. Let's look at, if we had 1 liter of a 2 molar solution. So this 2 molar, and that don't really look capital, does it? This 2 molar means that there is 2 moles per 1 liter. So if I had a liter bottle, that's a terrible drawing, right? How does that bottle look? More like that, I guess? I don't know. Not ours. I had a liter bottle. This was 1 liter, and it was slap full. Okay, this means that inside of that 2 liters, there'd be 2 moles. Make sense? All right, let's look at another example. Let's say that I had 0.5 liters. Let's say I got 0.5 liters of a 4 molar solution. Well, now this kind of means the same thing. So this means I have 4 moles in 1 liter. So if this was slap full of 1 liter, I would have 4 moles, but it's not. It's half a liter. So I have half of it. So I do not have 4 moles, I have less. I have about half of that liter's worth, which is 2 moles. So no. Maybe one more. Let's do 4 liters of 0.5 molar. All right, so now I have 4 liters filled all the way to the top of 0.5 molars. And what this means, remember, the mole is I got 0.5 moles per 1 liter. So in this 1 liter, there's 0.5 moles. In this 1 liter, there's 0.5. In this 1 liter, there's 0.5. In this 1 liter, there's 0.5, for a total of 2 moles. So that's kind of what the molarity concentration is telling us. How much mole is packed into 1 liter? But very rarely do you ever deal with just 1 liter. Maybe 4 liters, maybe half a liter, maybe 200 milliliters. So the molar is going to tell you that concentration. The concentration is always the same. Similar to if you have a full bottle of 91% isopropyl alcohol or rubbing alcohol. Whether it's full or half empty, it's still 91% alcohol. But if it's full, you have a lot more of the alcohol molecule than you do if it was half full, and vice versa. So kind of the last kind of point to make about that really is the bigger this number, the more concentrated it is. It's just that simple. The smaller that number, the more diluted it is, or the more watered down it is. But that is molarity. It's kind of like piles of sand, right? We count a whole bunch of small things. We put them into a pile, and then each pile we add is a mole, similar to the concept of a dozen. But it always is going to tell us the number of moles in 1 liter. Right? It's going to have a mass unit, which is the mole, and a volume unit, which is the liter, similar to density. And the concept of molarity is similar to density, where density is how much mass is in a base unit. All right, hope that helped. If you want to see how to use this formula, also similar to this formula here. Whoops. Check out part 2 on the molarity series. Also be coming with like just a mole video, probably closer to mole day.